In this lesson, we'll be looking at finding the area of composite figures. We have shape PQRS. So this is a quadrilateral because it is a four-sided figure, and it's made up of two triangles. So what we want to do here is we want to break these into two shapes, and we'll just start with that top triangle. Looks something like this. We can see that the height of this triangle is 9 centimeters, and we know that the base is 16 centimeters. The triangle that is below, I'm going to flip it so that it looks like we have a base and a height. It would look something like this. Our height of this was 7 centimeters, and the base was 16 centimeters. Our formula for area of a triangle is area equals 1/2 times base times height. Starting with the top triangle, we have 1/2 times 16 times 9. And we could look at half of 16 as 8. 8 times 9 gives us 72. So the area of this top triangle was 72 centimeters squared. And if we look at the area of the bottom triangle, that's 1/2 times 16 times 7. Half of 16 is 8. 8 times 7 leaves us with 56. So the bottom one is 56 centimeters squared. And then to find the area of PQRS, because the top part was 72 and the bottom part was 56, we'll combine that. 72 plus 56, when we add 70 and 50, that gives us 120. 2 and 6 gives us 8. So the area of PQRS is 128 centimeters squared. In this example, we have figure ABCDEF, and it's made up of a square CDEF and a triangle ABC there. So if we break apart this as two shapes, we'll start with the square. The square was EFCD, and because it's a square, that's 12 by 12. And then we had our triangle that looks something like that. First, we want to look at our base of the triangle. We have our height with that dotted line going across there. And our base would be this 6 plus that 12. So our base is going to be 18 inches. And then the height, because this part right here is 12, the remaining piece of 20 would make that height 8. So that is a height of 8. Starting with the square, 12 times 12. To find the area of the square, it's side by side. So that gives us 144 inches squared. And then our triangle would be 1/2 of 18 times 8. Half of 18 is 9. 9 times 8 leaves us with 72 inches squared. And then to find this total area, again, we would have to add up both areas. So that's 144 and 72. When we add 140 and 70, that leaves us with 210 plus 4 and 2. That leaves us with 216 inches squared. For our last example, we have a flower bed that is made up of a rectangle and a semicircle. We want to find the area of the flower bed, and we're going to use 3.14 as an approximation for pi. So we're given that we have a rectangle and a semicircle that make up the flower bed. Our rectangle dimensions are 10 feet by 16 feet. And because the base here is 16, that means that the diameter of our flower bed is also 16 there of that semicircle. The area of the rectangle, length times width, 10 times 16 gives us 160 feet squared. And now for the semicircle, we have to use that 3.14 as our approximation for pi. The area of a circle is pi r squared, and we look at that as 3.14 times radius times radius. If the diameter is 16, the radius is half of that 16, so that is 8 by 8. 8 times 8 gives us 64. When we multiply 3 and 1400ths by 64, that leaves us with 296 hundredths, and that is feet squared. But this 296 hundredths feet squared would represent if this were a full circle. It is only a half circle, so we have to divide that by 2. And when we take that 296 hundredths and divide it by 2, that leaves us with an area of 148 hundredths feet squared for the semicircle. So now we want to add these two together, and 160 plus 100 leaves us with 260 and 48 hundredths feet squared as an approximation for our area of this flower bed. And the reason we have to approximate is because we did plug in 3.14 for pi here, which is an approximation for pi.